Let Friends, let us continue with the numericals, in which we are going to find out the third part. Now, distance traveled by the block when the energy is released from the compressed spring. I hope the first and the second part is clear to you. Now, distance traveled by the block when the energy is released from the compressed spring. Prior to that, there can be three variations in such numericals. In these numericals, you can see here the angle is given. The angle of inclination is given as 30 degrees. So directly the angle will be given. Secondly, a slope can also be given as 1 in 100. So you can take here tan theta. Tan theta is equal to 1 by 100. So this will give you the value of theta. So that is one. And the next is gradient. Gradient will be given in percentage. 1% means 1 by 100. So again 1 by 100 is nothing but equal to tan theta, and you can take the value of this. So that will give you the angle theta. So the inclination can be given either in terms of angle or in terms of gradient or in terms of slope. This is one. Now we'll switch over to problems. This is the next question that I am going to take. A wagon of mass 50 tons. You can just go to the read the question. Now here in this case, the gradient is given as 1% and the rolling resistance, that is force of friction, is given as 6 newtons per ton. Now the weight of the mass of the wagon is 50 newtons. So for 1 ton the resistance is how much? 6 newtons. So what will be the force of friction? For 1 ton it is 6 newtons. So for 50 tons it will be 50 into 6. So the force of friction will be equal to 30 newtons. Here we are supposed to find out how much will be the compression of the spring, and second one is we have to find out the velocity with which wagon strikes the force. So I'll show you the question. This is a wagon which is resting on an inclined plane. This is a spring. Here theta is given because here grade is given as 1% and here the distance is 30 meters. Now one more change that you can find here is the buffer spring compresses 1 mm per 15 kilonewton. So the K value is 15 kilonewton per 1 mm. So it is 15 by 1. So you can convert this in terms of, so K will be equal to what will be K? 15 by 1. K will be equal to 15 by 1. So it will be equal to 15 into 10 raised to power 6 Newton per meter is the value of K that we are going to take here. 15 into 10 raised to power 6. 15 because this is in kilonewtons and this is mm. So we'll convert both of them in terms of Newton per meter. So we get K equal to 15 newtons. So when we draw the free body diagram, this will be something like this. First we'll find out the amount of compression in the spring. So we have found out the force of friction for 60 newtons per ton. So this will become 60 into 50. So the force of friction comes out to 300. So this is the free body diagram of the block. Weight 15 into 10 raised to power 3 into 9.81 is the weight. Sine component, sine theta. Theta we have found out by using converting 1% grade. Tan theta is equal to 1 by 100. So we get theta equal to 0.573. First is we are finding out the maximum compression in the spring. Again same thing. We will apply work energy principle. So at this position velocity v1 is equal to 0 and compression in the spring x1 is equal to 0. At this position maximum compression in spring means this will come somewhere here. At that point velocity will become equal to 0 because the block will continue to move until its velocity becomes equal to 0, and at that point the compression in the spring will be maximum, which we are considering to be x. So again we'll apply work energy principle. Again this direction is negative, downward is negative. So all this force will become negative, displacement is also negative, force of friction is positive, but displacement is again